Algebra 1 students, welcome to your 7.6 notes on exponential functions. I do apologize that we don't have music this evening. I tried to find the music and put it on here, but the iPad was not getting along with me. So, unfortunately, we're just going to dive right in. An exponential function is a function of the form y equals a times b raised to the x power, where a cannot be 0, otherwise that would make everything 0, and b has to be greater than 0, and b cannot be 1, because if it was just 1, well, then it wouldn't be an exponential function. So we've got a couple of examples here of y equals 2 raised to the x power and y equals negative 2 raised to the x power. And you'll notice, I'm going to turn on my laser pointer here, it looks like it gets to 0 and then just continues on to 0, but if you actually analyze this and take it further and further out and stretch this graph out, you would notice that each of these graphs approach 0 and they never actually touch it. If we were to really analyze it really well, that's what we would figure out, and we would figure out that we would have something called a horizontal asymptote right here, and that's where the graph doesn't touch it, or the graph gets, or the function gets infinitesimally close to 0, but never actually touches it. So even though it looks from this view like it does not. Same thing over here. It might look like it's getting to 0 and actually touching 0, but we have a horizontal asymptote, and that's the deal. So in our examples 1 through 3, the instructions are, is the table linear or exponential? So we need to analyze this and determine whether it's a linear function or an exponential function. And one way we can do that is take a look at our y values and take a look at our change in y. And our change in y between here and here, well, that's positive 3. Our change in y between here and here, well, that's positive 3 as well. And look at that, it's positive 3 again. So for number 1, we would say that that is a linear function. Number 2, we have a change, and we are actually subtracting 2 here, or we could say we are multiplying by 2. And I think it's important to take a look at that and say, hey, look, what's going on between here and here as well? So we're basically multiplying by 2, we're multiplying by 2, and we're multiplying by 2. Well, folks, that is an example of an exponential function. Exponential function. All right. And let's take a look at number 3. We've got y is decaying here. And how fast is it decaying? Well, we're basically dividing by 2. And then we're going to divide by 2 again. And again, we're going to divide by 2. And so this is also exponential. It is an exponential decay. And we'll take a look at that a little more in detail in class as well. So, oh my goodness, my handwriting is pretty terrible with this pen. There we go. That has fixed it just a little bit. So we have a linear table, we have an exponential table, and we have an exponential table for number 3 as well. All right, so for number 4, it says, suppose 30 flower beetles are left undisturbed in a warehouse bin. The population doubles each week. The function f of x equals 30 times 2 raised to the x power gives the population after x amount of weeks. How many beetles will there be after 56 days? Well, first of all, we need to convert days into weeks because it's asking us after how many weeks. And it's giving us a function in terms of weeks. So we need to take 56, divide by 7, and you'll figure out that that is 8 weeks. All right, so really what our function is going to look like, or what we're going to plug into our calculator, is going to be, and I'm going to plug this into my calculator, is 30 times 2, and I'm going to raise that 2 to the 8th power. And when I do that, when I take 2 to the 8th power, I end up with 256. So I need to multiply 256 times 30, 256 times 30, and that will give us 7,680 beetles. That's how many beetles I'm going to have after 56 days. All right? And so when you guys are doing these sort of problems, you need to give it some context. So you need to say it in some sort of sentence. And I wrote really fast. It was so fast you couldn't even see it. But after 8 weeks or 56 days, there will be a population of 7,680 flower beetles. All right, folks, for number 5, hopefully you don't mind. I did a little bit of calculation off screen where I had it paused. And basically what I did was I figured out what would happen. I kind of did like we did in class where I took my 3's and I just I plugged in a bunch of different exponents that I could have potentially picked to come up with my values, and then I just said, okay, well, let's multiply all those by 2. So that's where I came up with that table there, and these are basically my values that I came up with for my potential x values. But to give it better context to my function, I went ahead and plugged it into a t-chart right down here, and I didn't give myself enough space, so I kind of had to crunch some stuff in there. But before we take off from this page, we need to do some graphing. So let's take care of that. All right, so I went ahead and jumped off camera one more time so that I could figure out what I wanted to use for my x and my y, or I guess my values, if you will, or my scale of my graph. So now I'm going to go ahead and start plotting some points. My first point is an x value of -3, and my y value is 227, right down in there. So my next point is -2 and 2/9. So let's see, that's still going to be pretty close. And then we're going to have -1 and 2/3. Well, we're getting a little bit farther away from 0, but we're still kind of close. The graph should start looking a little more interesting as we head this direction. Once we get to 0, we're going to pop up here to 2. Still not even going to really quite hit 5, and I probably shouldn't have even put that where 5 is on that graph, because I probably should have used a different scale so that we could really get interesting here. But we're going to go 1 this direction, and we'll go popping up here to 6, so we'll just be barely above that line for 5. At 2, which would be right there, we're going to be all the way up here at 18, so now we can start noticing our graph getting kind of interesting. And then at 3, which would be there, it's going to pop up here all the way to 54, so just a little bit past that line. All right, and now our graph starts to get interesting, and it's kind of tough to draw this with these pens here and keep it straight or smooth. So let's see how Mr. Bear can do. Oh my goodness, my screen is flipping all over the place. Hopefully you didn't see any of that. I'm holding my breath as I try to make this line as smooth as I possibly can. And there we have our exponential graph. All right, for number 6, our function is y equals 8 times 1/2 raised to the x power. I again did some of our math for us, so that way we can go ahead and graph our function. And basically what I did was I just set up 1/2 and raised that to some different powers here. I chose some different x values from -3 all the way to 3. Figured out what I was going to have and multiplied that by 8. And then when I got to right about there, I started to notice a pattern developing where I'm just multiplying by 2 every time as I go upward. So I just started rolling with that and got all the way to 64 for x equals -3. So let's go ahead and choose our scale here. I'm going to choose this as -1, -2, and -3 is going to go right there, which means I'm going to have a 1, a 2, and a 3 going on this direction. All right, and so for my scale going the other direction, or for my scale going for y, I'm going to go by tens again, just so that I can fit my graph on my page here. I've got 10, 20, 30, 40, and 50, and I'm not going to fit it. Let's call this 60. 60 doesn't want to show up. There we go. All right, so I've got -3 and 64. So this time, my function's going to be right up there. Can you guys see that -3? I just went ahead and added another negative in front of that. It was probably sitting there. It just looks like my 3 had a big hat on it. Okay, -2 and 32. So I'm going to plot a point right about there. -1 and 16, so a point right about there. And then we are going to get interesting. We've got 0 and 8, so a point right there. We've got 1 and 4, so we're getting a little bit underneath that 5, 2 and 2, closer to 0, and then 3 and 1 right down here. I think you guys get the picture of this graph. And let's go ahead and draw our line. Hey, that line looks a lot better than my last one did. Mr. Bear got better at that. All right, so that is what our exponential function looks like in this case. Again, we have a horizontal asymptote right here at 0. It's going to get infinitesimally close to 0, but it will never actually touch it. So it's kind of one of those things. And then here's the deal. On your notes, you have a couple of more problems than we are showing here on the video. That is okay, because there is an activity I want to do with our calculators in class, and I know most of you don't have one of those graphing calculators at home. So for number 7 and number 8, we're going to work on those in an in-class activity. So come prepared for that. We will see you soon.